This is Vasvi from At Home. In this video, we are going to look at the nature of the roots of the quadratic equation. Actually, we know the roots of the quadratic equation ax squared plus bx plus c equals to 0. You normally have two solutions, right? You take it as alpha and beta, okay? So you normally have two solutions for it. But the nature of these solution could be found out earlier before solving the problem just by looking at its discriminant. So what is the discriminant here? By discriminant we mean b square minus 4ac part of the quadratic equation, quadratic formula, okay? We have the formula minus b plus or minus square root of b square minus 4ac over 2a, right? This part, the part inside the square root will be the discriminant. Find out the discriminant by solving for b square minus 4ac, and the discriminant we normally show in this delta form. This is the triangle which we call it as delta, okay? So the delta denotes the discriminant. If the delta, the answer of the delta is less than 0, is something like negative number, then you can say that the roots are imaginary, okay? It is imaginary because inside this part, this discriminant part becomes a negative number. So you don't have a square root for a negative number, or you may find the square root using the complex number, which we are not concerned right now. So in case if you get a negative answer for this discriminant, you can say that the roots are imaginary, okay? Now, just imagine what's if the discriminant, the delta is equal to 0. So when the delta is equal to 0, what happens is this whole part becomes 0, right? So you just have minus b over 2a for alpha, okay? The first root will be equal to minus b by 2a because the other portion is 0. And even your beta would have the same answer, like minus b over 2a, because the radical part is 0 here, okay? So that's why we say if the delta is 0, the roots are real and equal, okay? They are equal. Both alpha and beta are equal. They are real, but they are equal, okay? Now, when the when the discriminant is greater than 0, the roots are real but they are distinct, okay? You have two roots. Say for instance, for alpha you may get minus b plus square root of b square minus 4ac over 2a, okay? This is one answer. And for beta you get another answer, different answer, with negative sign in between, right? Like minus b minus square root of b square minus 4ac over 2a, okay? Likewise, you get two distinct answers, roots for this quadratic equation. I can make it even more clear with this chart here. See, if our delta is less than 0, here it is less than 0, we say that the roots are imaginary and they are not real. Imaginary means they are not real, right? So the delta can either be less than 0 or greater than or equal to 0 here, okay? Another option is greater than or equal. If it is greater or even if it is equal, you say that the roots are real, okay? The roots are real here. Now, when you know that the delta is greater or equal, you have again two options, right? It can be either greater or it can be equal to 0. Greater than 0 or equal to 0. If it is greater than 0, I told you, you have two distinct root, two unequal root, okay? One with plus and one with minus, okay? But when the delta, when the discriminant is equal to 0, though the roots are real, both the roots are the same. That is, your alpha will be equal to your beta. Okay. This side alpha is not equal to beta. Okay, now again the next classification is when the delta is greater than 0. When the delta is greater than 0, your discriminant may be a squared rational number, or it may not be a squared rational number. Okay, that means your discriminant may be a perfect square number, or it may not. Okay, if they are perfect square, you call it rational roots. Okay, if they are not, it is not a perfect square, then you call it irrational roots. So I hope you understand what is imaginary or non-real, when the discriminant becomes real roots, and when it is equal and unequal, then you have to know what is rational and irrational. Okay. So this is all about the roots, the nature of roots. In this chart over here, okay, you can see the nature of the roots when it is non-real. Okay, non-real in the sense imaginary, that is when your delta is less than 0. When you graph it, you see that it doesn't touch the x-axis at all. When the coefficient of a is greater than 0, it would be facing upward. And when the a is less than 0, when a is a negative number, then your I hope you understood what I mean by a. You have the coefficient of x square, right? If the coefficient of x square is positive, you have the curve facing upwards, and when it is negative, it faces downwards. But you can see that there is no roots. I mean, the graph doesn't touch the x-axis at all. Okay? Now, when the roots are real and equal, okay, they say equal. So when they say equal, then the delta should be equal to 0. So at this stage, look at the graph. If a is greater, then you know it would face upwards, right? But you see one answer, one point which is touching the x-axis, so that would be your answer. This would be minus b by 2a. And even if your a is negative, then it would be facing downwards, but still it would touch the x-axis at one point. So you have one solution, equal solution. Both your alpha and beta are equal here. Then the third is real and unequal, right? So you have real roots, but two different answers you get, two different roots. That is when your delta is greater than 0. So at that time you see that the graph touches the x-axis at two different points. Okay, one over here and another over here. And again, if the a is greater than 0, it would face upwards, and when the a is less than 0, when the coefficient of x square is negative, it would face downwards. But still you have two distinct answers. Okay, two distinct places it touches the x-axis. I hope you are very much clear about the roots, right? How it comes, like when it is equal to 0, when the discriminant is equal to 0, less than 0 or greater than 0. So these are the natures of the roots. Now I've just taken two problems to make it little more clear for you. Just two examples maybe. Here the question says, show that the roots of x square minus 2x minus 7 equal to 0 are irrational. Irrational means you should get a square, a non-perfect, okay, square number. Okay, I told you we can find out the nature of the roots by finding out the discriminant, right? You know the discriminant is b square minus 4ac, right? 4ac. Let's find out that. So that would be b square is minus 2. Here your a is 1. Your b, first write down this so that you're not confused. Your b is negative 2, the coefficient of x, along with the sign. and c is the constant number, which is minus 7. Okay, so here b square would be negative 2 the whole square minus 4 times a is 1 times c is negative 7. Okay, so this becomes 4 here, and this minus and minus sign together becomes plus 28, right? So that is 32. Your delta is 32. So 32 is not a perfect square, right? So what can you conclude? Therefore, the roots are irrational. I said when you cannot find perfect square for the number, then the roots are irrational. Understood? You have proved what they have asked you to prove. Roots are irrational. Now let's go on to the second one. Here they say for which value of k. Here they haven't asked you to prove anything, but you need to find the value of k. So for which value of k will the roots of this equation be real and equal? They say real and equal. So you know when it is real and equal, it should be, your discriminant should be equal to 0, right? Now first let's rewrite this equation properly, because it is not in the general form, right? So that would be 6x squared. Bring down the 4kx this side. So minus 4kx plus 6 equals to 0 is the general standard form. Okay. Now you can find out what is your a. Your a is 6. Your b is minus 4. Minus 4k, okay? And you need to find what the k is. And your c is 6, okay? So, and they say that the roots are real and equal. So, your delta should be equal to 0, right? Your delta is the discriminant. Okay, the delta formula is b squared minus 4ac has to be equal to 0. Let's plug in the values here. B square is minus 4k the whole square minus 4 times your a is 6 times your c is, again it's a 6, equal to 0, right? So this would become 16k square equals, I just take this, instead of calculating and taking it to the other side, I can just straight away take it to the other side. So what happens? This becomes positive 4 times 6 times 6. So now your k square would be equal to 4 times 6 times 6 divided by 16. So I can just cancel this. Your 4 would go here 1 times, here it goes 4 times. Now 4 goes here twice, here it goes thrice, and this 2 would go once, and this 6 would go thrice. So you got your k square equals 9. Okay, 3 times 3 is 9. Now your k is square root of this 9, and that is nothing but plus or minus 3. So k can either be a positive 3 or a negative 3 to satisfy this condition. Okay, so k is equal to a positive 3, or k can also be a negative 3, and that would be your answer. This is what they asked you. They just asked you what value can k take up. So k can either be 3 or negative 3. Hope you all understood what we actually mean by the nature of the roots, and how you apply that in the problems. See you all again with next set of problems. Bye.